Okay, on this video we are going to see how this piston of the shock absorber is being designed. Okay, so to do this we open part, open. So this is now our shock absorber design. Okay, normal 2, so it's look like this, right? So use settable boost base, so we go here. All right, so let's see the sketch. Edit sketch, normal 2. All right, so what plane did he sketch? All right, I think he sketched on the front plane. Okay, normal 2. So one line from the point of origin. Okay, until here. All right, and then 15 distance of 15 mm from the point of origin to this horizontal line. Okay, and then he make a vertical line. Okay, with a 50 millimeter, and then he make one diagonal line, all right, with a degrees of 60 degree. Okay, 60 degree diagonal line. Okay, so we can put it there, 60 degree. All right, so one horizontal line with 5 millimeter, and then vertical line with 10 millimeter, right, and then horizontal line. So this one is the midpoint. So the distance from this point to this point is 40 mm. Okay, and then I draw a vertical line, okay, until to this point with a distance with the center line of 7.5. Okay, so the length of this line is 150. Okay, so this line is 150, right, and then the distance over here is 7.5. So after that, he make another horizontal line with a distance from the center of 15 mm. Okay, so from this line to this line is 15 mm. All right, and then another vertical line. All right, the height of the vertical line is not stated, but until to the end is 25 with a 2 on both sides. The first is 5, okay, 5 mm. The second is 7. So the third will be 7 plus 5, 12, plus 2 plus 2, 16. So if the total is 25, so this is 10, right? And then the depth of the group, okay, is 2 millimeter. So 2 millimeter. So same group. So 2 by 2. So therefore this is a square. This is a square. All right. So this is the sketch, right? On the piston, the sketch is like this. Okay, we repeat, and this is 15. This line is 15. This line is 5, and this is small line here is 2. This is small line is 2. This small line is 2. This line is 7. Another 2, 2, and 2, and this line is 10. All right. So and this line to here is 7.5. So if that is 15, so this line is also 7.5. So after the design, the sectional view of the piston of the shock absorber, Okay, he revolved base, and this is the 3D of the part being revolved. So after that, he do chamfer. Okay, what did he chamfer? Okay, we edit. So he chamfer on this side with 45 degree by 3 mm. Okay, so check. So after the chamfer, he make one extrude boss here. Okay, he make an hexagon. So let's see the sketch. Okay, normal 2. Alright, so this one is sketched on the base. Okay, or on the origin, which is the top plane. Alright, it can be on top plane, can be on the base. And then the dimension of the hex using this sketch hex. Okay, he put a 15 on one side. Alright, so it means all 15 already. So close, and then he extrude both by how many mm? He extrude both by 10 mm. Alright, so meaning it moves here by 10. Check. So this is the nut on the bottom of the piston, okay, or the hexagonal. And then again he make jumper. So on this portion, let's edit. Where is this jumper? So he jumper this portion with 1 mm by 45. Alright, check. And then he make one extrude post. So for the piston eye. Okay, so on the eyelet, this is the sketch. Alright, normal 2. So this one, let's see where he sketch. Alright, it's not on the front plane, it's on the right plane. So sketch on the right plane. Okay, normal 2. So the dimension is 40 on the big circle and 20 on the small. Alright, you make one line, convert entity with this hexagon shape, and then the distance don't have, so let's measure the distance, how much. Okay, smart dimension from the midpoint of the circle and from this base of the hexagon part of the piston, okay, is 21.83. We don't need to change, so it's 21.84. All right, so the arc, how much the arc? All right, it's 3.43. We don't need to change. Check. So this arc also should be the same. They are the same, so meaning it was mirror. Okay, cancel. All right, so this and this it do mirror, that's why it's the same, right? So we close, that is the sketch. So this, what is important is this 21.84 from this point to this point. Okay, so close the sketch, and then let's see how he make the bows. All right, how much is that? So you use mid plane with 10 mm, so meaning the thickness is 10 mm. All right, so mid plane, right? So he select 3. What are these 3? We can clear, and we select 1, 2, and 3. So that is the 3 region he selected for this eyelet of the piston. All right, and then he make another extrude boss 3. All right, let's see the sketch. Okay, so it's similar there, it's still on the right plane. So normal 2. So the sketch is the same. All right, so I think is still the same, the one I just mentioned. Then we go on the next boss. So this is the sketch. Edit. Alright, normal 2. Okay, let's see where it is. Still on the right plane. Okay, still on right plane. And now the sketch is alright. So he offset entity on the small circle by distance of 2 mm, another offset entity. So meaning here he used this offset entity. Alright. And then he used this small, and then he used this as 2. Okay. So 2, that's why it's 2. Alright. So on the big, he also offset. Okay. So still offset entity. He used this edge, and then instead of going out, he reverse and then going in by 2 mm also. So this sketch is used, and then he extrude both. Let's see how much he extrude both. The first extrude both mid plane also now is 30. The first one is 10. This is 30. So how does it look like? So it become like this. Okay, it's bigger. So let's check. So it become like this. All right. So there is 2 mm there, 2 mm on that side. Now let's see what to do next. All right, click edit. So he chamfer the face. Phase 1, phase 2. This is phase 1. This is phase 2 to 2 mm by 45. Okay, and then check. So it become like this. So this extruded boost is just like the boosting of our piston of the shock absorber. Okay, and then fillet. Where is this filleting? See, where is it? Edit. Okay, he fillet on the edge of the shock absorber eyelet, right? And then check. So the design is done for the piston of our shock absorber.